Hello and welcome again to my Physics and Physical Science video lecture supplement series. For today's supplement, I wanted to go over a simple example that illustrates a bit about the difference between displacement and distance traveled. So let's consider a car that takes the following route. First, it drives 3 blocks to the north. So we'll call that x1. Then it decides to drive for 2 blocks to the west. Next, it turns south and heads 1 block south. And then finally, it goes 2 blocks to the east. So our question is, what is the total displacement of the car from start to finish? And how far does the car actually drive? In other words, what distance does this car drive from start to finish? So we could draw a little diagram, map, if you will, of the car's route. Maybe the car starts off here. And the first thing that it did was go 3 blocks north. So 1 block, 2 blocks, 3 blocks. Then it says that it went 2 blocks west. 1 block, 2 blocks. Okay, next, 1 block south. Puts us right here. And finally, 2 blocks east. 1 block, 2 blocks. So there's the end. So if we want to know how much displacement the car has from start to finish, we look at the start point, we look at the end point, and we draw a simple vector from start to end. A simple vector is just like this, so this would be delta x, the displacement. And to get that delta x displacement, we basically would have to take these vectors and add them together as vectors. So the vectors, this is the end of vector 1, this is the end of vector 2, here's vector 3, and here's vector 4. And so if we add these vectors up pictorially, we end up here at the end of the black vector. And at this point we can, for example, just count how many blocks we've traveled north and how many east or west. And we see that it's actually just 2 blocks straight north. Okay, so mathematically, what does that look like? Mathematically, we have x1, x2, x3, and x4 written out over here. We would want to maybe break those up so that any vector might be written as east-west, comma, north-south. Okay, so that means that x1, 3 blocks north, looks like this. 0, because it didn't go any east-west. North we'll call positive, south we'll call negative, so this becomes positive 3. For x2, it's 2 blocks, comma, west. So we'll say east is positive, west is negative, so this is negative 2 blocks, comma, 0 blocks. That's this part right here. Okay, third, there's the delta x3. And it was entirely south, and it was just 1 block. So 0, comma, minus 1 block. And then last but not least, there's delta x4, which is now positive 2 blocks, comma, 0 blocks. I'm actually going to rewrite this one like so. And the reason why I wanted to rewrite it like that, I suppose for consistency, maybe this one should be rewritten as well. Is because when we're adding a vector like this in Cartesian, we want to add up all the east-west components, and we want to add up all the north-south components individually. So east-west, we have 0, minus 2, plus 0, plus 2. So that's 0 blocks. And then over here in the north-south side, we have 3 plus 0 minus 1 plus 0. So that's plus 2. Okay, so we found our total displacement then. It's 0, comma 2, or as I've written it up here, 2 blocks due north. Okay, but how far did the car actually drive to do all this? Because there's a bit of a difference, and you'd notice the difference because you look at the odometer in your car, or you look at the amount of gas left in the tank. You're going to have a different amount of gas and a different change in miles if you drive from here straight to here and stop, than if you drive up to here, drive over to here, drive down to here, and then drive over to here. It's a different number of blocks driven, it's a different amount of gas used, there's a different amount of time in the car, and so on. So if all we want is just the total distance, delta x, we can just do delta x1 plus delta x2 plus delta x3 plus delta x4. And if all we're doing is just looking at the total distance traveled, we can ignore all this north, west, south, east, and we just look at these distances. And so we have total distance traveled is 3 blocks plus 2 blocks plus 1 block plus 2 blocks. Okay, so the car is driven 3 plus 2 is 5, plus 1 is 6, plus 2 is 8. So the car is driven a total distance is 8 blocks. As opposed to 2 blocks, comma, north, which is the total displacement. This also is a total displacement, 0, comma 2. So symbolically, we represent that difference by having these little vector arrows over the displacement and no vector arrows over the distances. And that's just to tell us the arrow basically gives us a point. It's pointing in some direction. And so displacement cares about direction. We have to factor in both the distance, or the magnitude, and the direction. This one, for distance, all we care about is how far. Only the magnitudes matter. It's a scalar. Okay, so that is basically a simple example on both distance and displacement, and from there you could do stuff like convert from blocks to meters. You know, maybe a block is 50 meters, or you could figure out how fast the car is going if you know how much time all this took, and so on. But this illustrates for us the difference between a displacement and a distance traveled. Another way of thinking of it is that on your typical day, your net distance traveled is how many steps you took for that day, plus how far you drive and ride the bike and so on. Might be many hundreds or thousands of steps, but your total displacement for the day, for a typical day, is hopefully 0, because you probably started in your bed or your hammock or whatever, and you got out of the bed in the morning, you went about your daily routine, and at the end of the day, you got back home, you got back into bed. And so you started in the same place, so you have a daily displacement of 0. So that's all I've got for today. I hope that you enjoyed watching this little video, and thanks for watching, and I guess I'll see you next time.